Hi, I'm Mari Peltola-Nykyri from Finland's Social Insurance Institute, and I'm here to tell you about our personal health record that is on fire. First of all, a few words about our Kanta services. The PHR will be part of the Kanta services that we already have in Finland. Kanta is the name of the Finnish national e-health infrastructure that is designed for healthcare, social services, pharmacies and citizens. And it is a centralized architecture. Also the personal health record will be centralized. And the goals of this Kanta service is to offer healthcare and social care professionals up-to-date information about patients' health and well-being and its history and services as a data mediator between organizations. And it decreases the need for local archiving and provides foundation for statistics, reports, research and other secondary use. Here is the overall architecture about our Kanta services. Here you can see the e-prescription service, patient data repository and the personal health record. The e-prescription service and the patient data repository are already in production, and almost all of our prescriptions are digital nowadays. And the personal health record is going to production next year. These systems that already are in production uses HL7 version 3 messages and CDA, but the personal health record will be done on FHIR. And as I said, the electronic prescription, it has been mandatory to create electronic prescriptions since the beginning of this year. And the patient data repository, all public healthcare organizations already store the data to this repository, and most of the private healthcare services have already joined the repository. And also we have My Kanta pages that is service to citizens where they can view their health data that is stored in Kanta services, and they can, for example, create prescription renewal requests, give consents, and so on. The goals of the personal health record ecosystem is to empower citizens to be more involved in their healthcare and promote self-care and responsibility, and promote preventive self-care and support self-care of chronic diseases. And it is really about the whole ecosystem that makes this possible, because the PHR part that we are creating is just like the storage part of this, but all of the services are created by other parties than Kela. And the PHR is a file server in which citizens may store information about their health and well-being and give consent so that the data can be used in healthcare. And the healthcare data can be different kind of observations or questionnaires and so on. And they may enter the data by applications that are developed by third parties. And for this application we offer the FHIR interface and the open national authorized data content model. Here are the principal elements of the PHR. At the top you can see apps for applications for health and social welfare professionals. They can be part of the PHR, or they can be separate applications that are integrated, for example, with Smart on FHIR. And then there are applications for citizens. And there are also MyKanta pages. There the person can see the data that he or she has stored at the FHIR server, at the personal health record, but he can enter the data. So the data will come from other applications. But the user can see all of the applications that he has authorized to use our platform. And he can remove the authorization if he doesn't want to use that anymore. And there are basically two parts of our PHR. There is the FHIR server, where is the FHIR endpoints, and that is done with Happy. But the storage layer we have done ourselves. There is no SQL database that we store the patient's data. And also there are authorization server that provides OAuth endpoints, and this server contains a list of the certified applications and pseudonymization service. We don't use the real patient identification in PHR. We give the pseudonymization ID for the applications, and that will increase the security. And there are also the authorization services for citizens, and also the tokens and authorizations are stored there. We use the Suomi.fi e-identification service to authenticate the citizens at the authorization server. And also in the future we will use the digital authorizations when someone can store data on behalf of someone other. We have published our profiles at Simplifier, and besides those profiles there are also implementation guides, example resource instances and so on. And and here's overall description of our development process of the national data model. This process encourages participation in the development of the data model by enabling the submission of development proposals related to the data model. So it isn't some national organization that says that okay, only these things are stored in PHR, but anyone who develops applications that are connected to PHR, they can suggest a change in data model. And those proposals are reviewed and accepted or rejected by HL7 Personal Health Special Interest Group and Kela. The review is focused on the feasibility of the development proposal to the Finnish PHR data model, and we check these following issues. The international perspective, we check if there already is a model that we could use so that it could be like international compatibility. And the feasibility of from the perspective of FHIR standard and feasibility from the perspective of the promotion of welfare. And the interoperability, international and national. And we see that there aren't any overlaps with the existing data model. Also, we check that if any other parties are interested in this data model and do they have something to add to that, or would they like something to be removed from the profile. And we make sure the integrity of proposed value sets and code systems. And possible change requirements in the national Finnish PHR platform are also checked. For example, if they want to use new kind of resource that we don't have the support for that yet, and we have to do like indexing on the database and so on. So that means that the platform will be changed. The development proposal will be accepted only if the existing data model doesn't cater for the need behind the proposal. The overlapping elements that, for example, differ only in the name of the element won't be accepted. And as the data model is public, all development of the data model will be published as well. There are different roles in the acceptance process of the data model. Software vendors can propose the change, and Kela checks the change with HL7 Personal Health Special Interest Group, and DHL, the National Institute for Health and Welfare, is responsible for the preparation of national code systems to be used in Finnish PHR. Here's the process flow. First there is a need for the change, then an optional initial review. That means that the actual data model doesn't need to be final, but they can say that, okay, we need to store blood sugar levels to the PHR. After that, the profiles are stored to Simplifier, and they ask for official review. And then they present that profile on the HSO special interest group, and we will officially review that. And if there is a need for change in the platform, that will be done after that. And then after the profile or value set or so on is approved, then the testing can begin. These profiles don't get like final status until those are tested on the pre-production environment by someone who uses that profile. Okay, lessons learned. Choosing to FHIR was absolutely the right choice. But it was kind of a surprise how much time it takes to create the profiles, because basically the profiling itself is quite simple. You just choose the right, for example, for observations, you just choose the right codes and choose the right value type and so on. But the details are the one that takes time. Like, there must be right kind of reference to the value set and so on. And the commenting and validation of the profiles takes more time than creating the actual profiles. Therefore, we have created a simple way to add profiles to national data model. But it can be used only with observations and vital signs of the observations. If there is need only for new vital sign profile, then they can just pick the suitable point code and follower type and unit, and we will do the technical profiling. We just take our base profile and deliver it from that. And thank you. More information about our Kanta services and PHR can be found from Kanta.fi. Those pages are also in English, and you can send questions to our chat file or stream. Here's the address to that, and also you can ask from me. Thank you.
Look before when we tested it. So, welcome. My name is Alexander. I'm here with my colleague Andreas, Andy, sitting over there. I'm happy he is with me, because he is much longer with the topic than I am. I'm very new to the company and to the whole topic of clinical data and FHIR, working there for 2 months now. So probably I will transfer any difficult questions over to Andy once we come to this. We work for an Austrian company who is selling a universal archive for medical data. We operate mainly in the German area, so Austria, Switzerland, Germany. The main fact I want to bring up with this slide is we have some really large installations. So we have hospitals, or groups of hospitals treating data with our universal archive with like 500 terabyte of data, 10 terabyte per month new data, and more than 1 billion files on the server. So there are large systems in our company, and everything we develop or do has to take this into account. So it's not that we can just implement something because it's nice, it's a new standard, comes up, we make it happen. We have to take into account that it has to work on a scale like this, so with very large data files, moving data between different locations, etc., etc. So what we provide is trying to provide is a complete solution, a universal archive, and as such we're dealing with DICOM, non-DICOM, we speak HL7, we can deal with XDS, which is part of the standard that is used for the national patient record in Austria. We also provide RESTful web services, so it's not old-fashioned like this, it's relatively modern. We also provide clients, which is not part of the topic today, of course, but I want to mention it. So we also deal with displaying data, mainly for radiology, PACS systems, but with the extension to FHIR, we also need to account for displaying FHIR data. So on our way to what we call a universal archive for healthcare content management platform, we are mainly triggered by customer needs, customer requirements, so it's not like we go out there and implement our own FHIR server and do everything we want and it's just a playground for our developers. That would be nice for them. Andy would like it. Sales likes it too. They are happy with FHIR. They can sell apps and smart on FHIR and everything. Myself, I'm a production manager, product manager. So we have to deal with all the requirements on one side and on the difficult implementations on the other side. What we try to accomplish is we take what you see in the upper left, our existing document archive with all the pros and features that we have there. So it's like all the auditing thing, data redundancy, etc. And try to add FHIR capabilities on the other side. The whole requirements stem from a research project in one of our customers' hospitals. They came to us and said, we have a research project, we generate data, we send you HL7v2 messages containing those data, more or less observations. We want you as a universal archive to store it and make it available in a structured data, in a structured form. So we were thinking about how can we do that? And to us it was a possibility to get into the topic of FHIR. So two of my colleagues were here last year and got into this whole topic, and now we set up a FHIR server, trying to grab all these HL7 messages, converting them to FHIR, storing them, and delivering them out to this research project. Probably the talk I give is not answering any of your questions, how to add FHIR capabilities to an existing repository, simply because we don't have questions for all, we don't have answers for all the questions. Probably it poses more questions along the way. Nevertheless, I want to show you what we came up with as a solution for us, at least. What you see in the left column, more or less, and the green header document archive is our existing document archive. So it's a very, it's an old system, I would say. It's very robust. It's very flexible in handling different tasks. The main database model, I would say, is depicted here. I mean, it's more complicated in reality, but at the very central is a table called documents that stores all the metadata for the documents. We have a patient relation, of course, and we have DICOM and non-DICOM data. That's in database, specifically a Postgres database, but can be added, could be added anything else too. It was an Oracle before, now we switched. Below, you can see we persist everything on a file system. I mean, that's the reason why you want to have an archive. So we store all the DICOM files, all the images, PDFs, JPEGs, everything that we get on a file system. We have our own file system protocol for high throughput, etc., etc. So now that's the left side. That's what we have. Now we're going to extend this to talk FHIR, to store FHIR. And the approach that we did is the right column. Now you could say, okay, it's just 3 resources that you see up here. Yes, because that was the requirements from the customer. They need to store mainly observations, sometimes embedded in the diagnostic report, and they want to have medication administration first. What you can see in gray below, patient, practitioner, organization, and audit event, is something that we don't have as our own FHIR resource, but we map it to an existing table that we already have. Of course, we had a patient before, so it's nothing new to us, but we decided not to make it a totally new thing just because we invent, or just because we add FHIR to the whole system. So we reused our patient table, patient resource, and of course you can send it out as a FHIR, in a FHIR way, so you can read the resource and deliver it via FHIR. For the others, diagnostic report, observation, medication administration, what we do is we take the same approach that we did before with all the other DICOM, PDF, etc. We split it up and they live a dual world, you could say. So if one of these resources comes into the system, we store it persistently as a FHIR document in XML on a file server. That's the lower right part. At the same time, we store all the metadata that we are interested in, that you need to search for in the AIM document, so it's our own kind of document. So that's the link to the existing system. And at the same time, we store the whole JSON thing, the whole JSON diagnostic report, observation, etc., as a JSON-B in our PostgreSQL database. So it's maybe not the solution for everything, but it's what we foresee as a safeguard against changes in FHIR, you could say. And that's what I took away from the last day and also today. There were discussions going on in the Birds of Feathers sessions. Where do we go next? Do we do subscriptions, or do we change this to event type? How do we do querying? Do we go to GraphML, or do we do something else? So we want to be prepared for that. We don't want to exclude anything of that. So that's why we store everything. Up to now, we store it as XML in the document, so we can easily deliver it as a narrative, etc. We do the same. On the other side, we do it as a JSON-B, and Postgres is quite good in querying JSON-B as such. So you can do easy querying. You can, if you have your indices made right in the PostgreSQL database, you can do lots of querying. So at the end, what we try to accomplish is what you see at the very bottom and at the right up here. We want to take what we have from the original archive, so all the pros that we have there, redundant data storage, access control, lifecycle management, read write once, write many storage, etc., and add all those capabilities over here. So we want to search for FHIR things. We want to have accurate metadata batching. So we want to ensure that if an update is coming on a FHIR resource, that's going to be reflected on the document archive, of course, all this together. It's not easy, but I think we did a good task, at least for these 3 resources. We don't say that there can't be more, but those were the first we started with. Before I show you some of the roadmap, I want to say we have a cloud server running. If you want to test or want to ask something, please approach us. We can't put it public on one of the lists that you mentioned, because there is some data in there that you are not allowed to see. But if you have any questions or want to try it out, it's publicly accessible on the web. What I want to show you is our, I first put it on slides, then I removed the slides because it was changing since yesterday all the time. So I kept it in the mind map. So our roadmap or our needs, probably one of you has some answers for me on that, is, I call it forwarding here, so the requirement is that external systems like decision systems, etc., need to be informed about updates of our data. We know there's this subscription thing in FHIR. Yesterday there was a fierce discussion about it. Is this going to be changed next release, whatever? So, we have our own proprietary system, but probably we can make usage of the FHIR resources here, or FHIR paradigms. On the roadmap, as I said already, it's more like a buzzword, but sales likes it. Smart on FHIR. They can go out and sell everything with this buzzword. With this opening of an archive to the outer world, you would say, you getting more problems than before, especially Graham had a talk before. Security is an issue then. How do you authenticate or authorize users? So with this question, there comes something like OAuth, OpenID Connect, etc. We don't have that yet. We don't exclude it from our thinking, but it's not on the major. It's not a major focus now, because our systems mainly live in a closed ecosystem, you could say, in a hospital, for etc. They have their own network, more or less. So it's a pretty secure thing, but what we already have is web access to data, just because people want it and need it. So we have a HTML5 viewer who's capable of displaying DICOM images on handy, in a mobile phone. Although it's not allowed for diagnosis, of course, but that's how practitioners work. Yeah, that's just it. So we support it, but yeah, it's not open to the overall world, I would say. So it's a closed ecosystem, but we see that the pressure, or I wouldn't call it pressure, I would call it the requirements are coming on the horizon to open those systems to more than just the hospital itself. So that's definitely something. Probably you know R, the script language for the statistics. Could be something we are going to, just because customers come to us. Yeah, they say you're Universal Archive. You have everything in there. Nice, but we want to go and analyze it, and you can do it with simple SQL queries, of course. You can get out some information with that, but if you want to do projections, regressions, etc., you need more than that. So that's something we probably go into it. If anyone has experience with that, I would be more than happy to talk to him. Just approach me. Yeah. With that, I end my little talk, and I'm happy to receive any questions. If not, have a nice lunch. Thanks.